All right, this is a first law problem. It involves one substance losing heat, some other substance gaining heat. In this case, we have aluminum that's initially at 100 degrees C that's put into a sample of water that's initially at 20 degrees C. So the aluminum cools down, the water increases in temperature, the water warms. So there's a loss of heat from the aluminum and water's gaining heat. Now when we calculate delta T, it's different for the aluminum versus the water. But in each case, we calculate it the same way, the final temperature minus the initial temperature. So for aluminum, the final temperature is 25.33. The initial temperature is 100. So the result is a negative temperature change. For aluminum, the temperature change is positive. It's increasing in temperature. But still, it's calculated the same way, TF minus TI. So TF, 25.33, and we're subtracting 20 because that's the initial temperature change. So we have temperature change difference for aluminum versus water. We're going to calculate the heat the same way we've been doing it. Heat equals mass times specific heat times delta T, except when we substitute in our values, for heat lost, we're going to be substituting in values for aluminum, and for the heat gained, we're going to be substituting in values for water. Here are the appropriate values substituted for mass, specific heat, and change in temperature. Here it is for aluminum. We don't know what the mass is. That's what we're solving for. So mass times specific heat times delta T. For water, mass times specific heat times delta T. Notice I chose appropriate specific heats such that the unit of heat was consistent for both of these. Now I'm going to multiply these out, and for clarity, I'm going to ignore units. And here we've worked through the algebra to get to our final answer. So the negative 16.08 comes from multiplying these values together. 799.5 comes from multiplying all of these together.